Hello, my name's Nick Thody. I'm the Head of Knowledge at Osborne Clarke. And I'm joined today by Catherine Hammon, our Digital Revolution knowledge lawyer, for another of our talks on the fundamentals that underlie the digital revolution. Hello, Catherine.
Hi.
So today we're going to talk about the Internet of Things. And let's do as we always do. Let's start at the beginning. And can you briefly tell us what the Internet of Things is?
Yeah, sure. So the Internet of Things is the expression we use for the increasing network of ordinary everyday things which are having power added to them, computing power, energy, plus a connection back to the internet, whether that's mobile or fixed, and they are starting to send and receive data.
Okay, so this sounds sort of more familiar to me than other topics we've discussed, such as blockchain. So we're talking about some technology that's effectively building on what's been around for a decade or two.
Yeah, so we started off with the Internet of People, connecting from computer to computer. First of all, that was fixed wire, then we got mobile connections, smartphones, etc. We can do all sorts of things on the old internet, if you like, the ordinary internet that we're all very used to. And the Internet of Things is sort of an extension of that.
So why are we talking about the Internet of Things in our series about the digital revolution if it's actually quite old news?
So we've had the Internet of Things, it's slowly been building up over quite a few years now, and you're right, it's much less unfamiliar than blockchain is or artificial intelligence is in the sense of machine learning, deep learning. It's much less of an unknown thing. But the point about the Internet of Things is really the potential for where it can take us, particularly once you start to incorporate into it artificial intelligence functionality or blockchain systems, etc., some of the other new technologies which are coming around. And it's really the potential of where it can get us to, which is really exciting. And
I know, because I've heard you talk about this before, you always give the example, or you often give the example of a connected fridge, which, although in some ways might be seen as something one doesn't particularly need, is a good example of these sort of connectivity issues.
Yeah, so I use that because I always think it's easier to talk about the impact of technology in a way which is just straightforward and around ordinary everyday life. At the moment, the smartest of fridges at the moment has got cameras in it, and you can remotely tap into those cameras. And if you're in the supermarket and you can't remember if you've got any mayonnaise left, you can literally, via your phone, look in the fridge and see if there is any. But if you start to think about where that fridge could go, what if it had sensors on the shelves so it could measure itself whether the milk was getting low? What if it had a connection into your internet shopping so that it can, when it feels the milk is getting low, it adds milk into your internet shopping basket online? Or perhaps you've given it permission to pay directly and so it automatically replenishes your fridge with milk. What if it's connected to the weather forecast, etc.? It knows that if it's going to be a chilly day on Friday, you'll like a bottle of red wine. If it's going to be a warm sunny evening, you might like some rosé to sit in the garden and drink. So you can see that the more connectivity these devices have, the more automation we give them, it becomes incredibly convenient, it becomes incredibly easy, and they can start to simplify some of the things.
And that's on the kind of consumer side, but I guess when you're talking about large industrial processes, you've got the similar arguments that this enables a connection up of processes within, for example, a manufacturing system, and also the monitoring of the various elements of that system, so you can see where things are going wrong, where maintenance may be needed, and ultimately to generate data to improve those processes.
Yeah, absolutely. And the other really interesting thing around manufacturing processes, you've mentioned sort of predictive maintenance, you've mentioned efficient processing, all that sort of thing. One of the other things you can do is build a digital twin of your system. So you take all of that real-time data coming from all the elements within your production line. You can then create a virtual replica of your whole system, and you can use that to work out why is there a pinch point there, or why is that bit not working as efficiently, or if I retool along this section, what impact will that have? And you can start to use that for really fantastic planning processes, making your factory work in the most efficient way that it possibly can, making sure that changes are implemented swiftly, successfully, without kind of iterations to get it right, etc. You can do that all virtually using digital twins.
Okay, so I get the consumer application of it. You use the example of fridges, and of course the manufacturing and industrial side of it in terms of monitoring and improving those sort of processes. What's actually involved in the Internet of Things and how it functions?
Yeah, so as I said, it's sort of a continuation of the normal internet, the internet It connects people. Sometimes Internet of Things devices are still connecting back to people, so I can use my phone perhaps to access some of the functionality in my house, to control the heating before I get home, to open the garage door before I get home. Sometimes the Internet of Things devices are actually connecting one to another, talking to each other. So at some point down the line where we get connected autonomous vehicles, we will get platooning of vehicles. So a fleet can essentially operate almost like a swarm, knowing exactly where they are. They can move together much more closely as a block, which will be more efficient in terms of slipstreaming, using less energy, using less power, using the aerodynamics, etc. So you've got two broad areas: Internet of Things devices which connect back to people, and ones which are talking to each other.
And of course, when we say the Internet of Things, it kind of makes it sound like the existing Internet, which works effectively, completely seamlessly. But the Internet of Things is a much more complex concept, isn't it? And it doesn't, it's not one single thing. It's the connection of different technologies, different types of connectivity, and so on.
Yeah, that's right. So there's lots and lots of variation in how these systems are set up. Some Internet of Things devices connect very closely, so my wearable device on my wrist is just going to my phone. On the other hand, some things have got SIMs in them, and they're connecting directly from the Internet of Things device straight up into the mobile network, wherever the nearest mast may be, for example. So you've got differences in the distance they need to connect. You've got differences in the technology by which they're connecting. So is it 4G, 5G's coming, is it Wi-Fi, Bluetooth, and there are also some proprietary communication systems which are being created specifically for particular purposes. You've got differences in the architecture of these things. Is it cloud computing? Is it all going back up to the cloud? Is it edge computing? Is it being done much more locally where it needs to be done? You've got differences in the degree of integration with other technology. So it's not just Internet of Things, it's also got some artificial intelligence functionality. It's sending the data back down to be locked down into a blockchain, etc. Lots and lots of variations. Some of these things are starting to be standardized, but there remains a lot of fragmentation around.
Yeah. So different access points, different connectivity, different standards, different types of technology, and different kit. I think an obvious challenge, therefore, is going to be cybersecurity. You know, we've seen the classic examples in the press of children's toys being hacked, home security cameras being hacked. What's being done about that?
First of all, there are existing obligations around cybersecurity obligations around network resilience. So you are obliged to public network operators already have obligations on them which come out of the Communications Act. There's new European Union legislation coming into force, the NIS, the Cybersecurity Directive, which will oblige operators in certain sectors, energy, transport is included, digital infrastructure, various different sectors. So if your Internet of Things device is within one of those sectors, this may apply to you. And it basically is obliging the network operators to make sure that their systems are as secure, both in terms of not going down and also in terms of vulnerability to attack and to hacking, etc. Making sure that they apply state-of-the-art technology and protections into the system, making sure that they're updated properly, making sure that they report downtime or report attacks, etc., etc. That's all coming.
And another aspect of cybersecurity, I guess, is historically a lot of emphasis has been put on the end user of a piece of equipment in terms of passwording. We've all got the very challenging experience of trying to remember lots and lots of different passwords and so on. But I think there's a general shift into changing that into an onus more on manufacturers and designers to include security as a fundamental starting point when designing this type of equipment and devices.
Yeah, that's quite right. There's recently been a proposed code of conduct issued by the Department of
Culture, Media and Sport.
That one, DCMS. And the proposal, exactly as you say, is that the onus should now be on the manufacturers to basically stop, to remove from consumers the option to be a bit lax about all of this. So things like individual devices must have individual passports, not a generic factory default password. It must be easy to update the devices, to upgrade the technology, to upgrade the hacking protections, etc., that sort of thing. It must be easy to report vulnerabilities back to the manufacturer, basically to make it easy for us to have good cybersecurity around our home devices. Because, of course, increasingly we're learning to do it, but you don't necessarily think of a connected toy as being a computing device. and you have to go back to the website and back. It's easy to be not very good at the security around these products, and so the emphasis absolutely. Some of it's coming from the government, some of it's coming from the corporate world. There are corporate initiatives as well for security by design.
But there's also a cultural challenge around people actually understanding that what they bought is actually a device, that can be accessed.
Yeah, that's right.
So moving on from those sort of cybersecurity and access issues, the other thing the Internet of Things is doing, and this is kind of its raison d'etre, is moving around an awful lot of data. Yeah. So as soon as we're talking about data and data moving, we're talking about data security and data privacy issues.
Yeah, that's right. So we can't talk about data without talking about the GDPR, the General Data Protection Regulation, which is in force in May. The usual obligations apply to Internet of Things devices. You need to make sure that the data subject knows that you're collecting data about them, that they've consented to that, or that there's one of the exceptions applies, legitimate use. You need to make sure that they understand the rights attaching to their data, so the right to be forgotten, the right to have that data corrected, the right to take that data and move it across to a different system. There are obligations around reporting data protection failures, etc. Yeah, the GDPR is absolutely this is one of the absolute target areas for GDPR, if it's personal data, if it's sensitive data. And also, of course, the GDPR incorporates into it, we were just talking about security by design, one of the GDPR principles is privacy by design. So absolutely the expectation on manufacturers increasingly is that they set these products up to protect our data and to deal with it.
And just on that privacy point, what's happened to the e-privacy directive that was going through the Brussels legislative machine and was meant to sit alongside the GDPR but isn't on the statute book?
It's basically got stuck in discussion between the EU institutions. You're quite right, it was supposed to come into force alongside the GDPR and to sit beside it. In fact, what's happened is the GDPR is now very comprehensive, and unlike when the previous data privacy legislation was put in place, the internet wasn't really with us, and so you needed a second piece of legislation to add in the new gaps where internet trade and that sort of thing had come up, e-commerce had developed. Now, of course, e-commerce and the internet's fully integrated into our commercial world, and the question here is now actually, do we need this second piece of legislation? If machine-to-machine communications include personal data, then the GDPR covers them. And if they don't include personal data, then do we actually need to protect them? That's the debate that's going on at the institutional level.
So we don't know whether it will eventually emerge or not.
Well, I've seen an indication that the Commission hopes it'll be out next year, end of next year, but that suggests that the debate will be resolved in their favour, which obviously that's not clear yet.
Yeah. Okay, so I think one of the things we've noticed in these talks is, and particularly when we talked about artificial intelligence, competition issues are coming to the fore in a lot of areas of the digital revolution. And I think this area of the Internet of Things is another area where, slightly unexpectedly perhaps, or a sort of series of second-order consequences, is there are competition issues being thrown up. Now, you're a former competition lawyer, or still a competition lawyer. We never forget what sort of lawyer we are. Do you want to expand on that a little bit?
Yeah, so again, the easiest way to talk about it is to go back to my example of the fridge. If my fridge knows that I'm running out of milk, and my fridge manufacturer has an exclusive relationship with a particular supermarket, then it will get the milk for me from that supermarket. If my fridge, for example, is, if I organise my fridge, interact with my fridge via my personal digital assistant, perhaps that personal digital assistant either has an exclusive relationship or a preference for a particular supermarket, or perhaps it's part of a network with its own shopping channel, its own shopping online shopping system, in which case it will order the milk from that for me. Now, that's fantastically convenient, it all gets done for me, I never run out of milk. But at the same time, the price of my milk is driven by the fact that I've got the choice not to buy my milk from that supermarket, but to buy it from that supermarket. Now, if my fridge is making all of those choices for me, and because of the convenience, I don't really question it and I go along with it, you can see that adds up into a gradual reduction of competition. If that's how the market progresses, which is, this is all speculation at the moment, but if that's how the market goes forward, there are big challenges around maintaining competition, because automation is fabulously convenient, but it does sometimes remove the active exercise of choice by consumers. if choice is reduced, competition will reduce. If competition goes down, then prices will tend to go up, quality will tend to go down, innovation, new ideas, etc., choice will reduce. So that's one of the competition areas. The other thing is really an extension of the current issues which the European Commission is grappling with, where you have digital businesses which run platforms and through those platforms generate a huge amount of data. Does data equal power? Is data some kind of essential facility tool which people have to have access to in order to be able to compete in this new world? So those kind of issues are only exacerbated by the big data that the Internet of Things throws up as well.
Great. So as we've seen before, new technologies and new concepts to which old theories, whether it's in competition law or otherwise, may have to be applied or adapted, or completely new theories developed.
Absolutely.
Catherine, once again, thank you for talking us through the basics of the Internet of Things. It's very much appreciated.
Thank you.